Good morning, students. Welcome to the physics class of Aryabhatta PU Science College, Vinovanagara, Shumaka. Now, in the previous class, the third period, you have studied the electric flux, electric charges, electric flux. Now, in this period, you are going to study the further information about this electric flux and detailed study of this electric flux, the fourth period of this period. So, now in the previous class you have studied what is the electric flux and what is electric field lines, that you have studied in that class. Now, what is the electric flux? Number of lines of forces, so acting from the point charges, number of electric lines of forces acting together, acting at a point, is the electric flux. Now, you have studied mention the SI unit of electric flux. Mention the SI unit of electric flux. It comes into March 2020. So, very important. Newton per Coulomb meter square is the electric flux. It is the NSI unit of electric flux. SI unit of electric flux is N is Newton per Coulomb meter square. Newton per Coulomb meter square is the SI unit, and electric flux is a scalar quantity. It is a scalar quantity. So, write the expression for the electric flux through a surface. So, you see here, what is an electric flux you have studied? Electric flux means suppose a positive charge is there. Positive charge, a number of field lines, they are acting from the point, that is called electric flux. This is electric flux, these are the electric fluxes. So, mention expression for this one. The expression is there is no derivation in this topic. D phi is equal to E into delta S is equal to E is equal to delta S into cos theta. So, what is delta phi? Delta phi is the electric flux. Delta phi means very small, it is not visible from our naked eye. So, it is delta. Delta means very small quantity, and E into delta S. E means E is the electric field, delta S is the area of a small element. Small element means how much electric flux flowing through this given element. So, that is electric flux. Suppose this is the object, if a number of electric lines forces are passing through it, so this element is the delta S. Delta S, it is not a big size, it is very small size. So, it is delta S. And theta is the angle between the direction of electric field and normal to the surface. Angle between the direction of field, you see in this direction, the angle between this electric flux and this plane is the delta, that is theta. So, del d phi is equal to E into delta S, E into delta S cos theta. Delta P is equal to, delta phi is equal to electric flux, delta S is equal to area of small element, E is equal to electric field, and theta is equal to angle between the direction of electric field or normal to the surface. So, that is. Next, what is the dipole moment? So, in next topic is dipole moment. Dipole moment means, di means 2. 2 means one positive charge is there and another negative charges is there. These are the same quantity. If it is 1 coulomb, this is also 1 coulomb. This is 10 coulomb, this is also 10 coulomb. So, equal magnitudes. So, two point charges, they are opposite in charges but equal in magnitude. So, that is called a dipole. Dipole means a set of two equal and opposite charges. A set of equal and opposite charges, it becomes a dipole. Di means two, one pole and another positive and negative poles. That is two. The distance between them, distance between them is 2d. 2d is the distance between them. We are not going to measure only d, it is 2d, because positive charges half distance is there, for negative charges another half is there. One distance between the q and midpoint is d, and distance between the minus q and the midpoint is d, so totally 2d. 2d is the distance between the charges. So, what is dipole moment? And electric dipole, an electric dipole is the set of two equal and opposite point charges separated by a small distance. It is separated by a small distance. That is dipole. Di means two, poles means either positive charges or negative charges, or it is a set. It is a set means one positive and negative charges, equal positive and negative charges. So distance between them is 2d. So that is and it is SI unit is meter. Dipole is SI unit of dipole is meter. It is very important, and it comes in March 15th, and model question paper 2021 it is there. So you have to write it here. Take a. And next one is, what is the net charge of an electric dipole? You see, this is positive charge, this is a negative charge. The total charge on this is plus q and minus q cancels each other and equals to 0. So if it is a plus 3q and it is minus 3q, the total charge is plus and minus cancel 0. The total net charge on a dipole is always a 0. So the net charge, you see plus q and minus q, net charge is always a 0. So what is the net charge of an electric dipole? It is 0. So what is the dipole moment? Dipole moment means, so it is a dipole, you see, it is a set of positive and negative charges. Moment means one of the multiplication of momentum you have studied in the first POC. Momentum is product of mass and velocity. In the same way, moment is the product of one of the charge and distance between the two charges. That is called the dipole moment. Dipole moment is the product of one of the charge into distance between them. That is 2d. So what is dipole moment? Dipole moment of an electric dipole is the product of one of the charge and the distance between the two charges. Dipole moment of an electric dipole is the product of the one of the charge and the distance between the two charges. That is, its SI unit is coulomb meter. So coulomb meter is the SI charges. Coulomb is SI unit of dipole moment. Product charge is coulomb and distance is 2d, means that distance is meter. So that is coulomb meter is the a dipole moment, and especially dipole moment is a vector quantity. You see, vector quantity is this is a, and its direction from minus q to plus q. Minus 2q to plus q is the direction of the dipole moment, and the SI unit of dipole moment is coulomb meter, and dipole moment is a vector quantity. So, and its direction is dipole moment vector is directed from negative to the positive charges along the dipole axis. Dipole axis means, you see, this is the axis, dipole axis. This is the positive straight distance, that is the shortest distance between plus q and minus q is the dipole axis, and its direction is along the dipole axis from negative to the positive charge. What is the direction of dipole moment? Dipole moment vector is directed from negative to the positive charge along the dipole axis. Along the dipole axis is that is the direction of the dipole moment. Next one is, mention the expression for the dipole moment. Here it is a plus q and minus q, and this is the dipole axis, and distance between the q and plus q and minus q is always 2d. So we are always measuring the distance between plus q and minus q is 2d. In the problems it is arises here. So the dipole moment means is the product of one of the charge plus q and distance between the two charges, that is 2d. Q into 2d is the distance between, that is the expression for the dipole moment. In a vector form, it is p vector, unit vector p is there, this is the vector form. So that is. So next one is p is equal to q into 2d into p. So that is. So what is, so where p is equal to dipole moment, q is equal to charge, 2d is equal to distance between plus q and minus q, and p cap is equal to unit vector along the dipole axis. This is dipole axis. And today I think that you understand it very well. Then sketch the electric field lines in the case of electric dipole, and 2 positive charges and negative charges. That is question is there. This question and next question are also same here. You say dipole axis, that is the electric lines of forces. In the positive charges you have studied this plus Q. In the case of positive charges, the electric lines of force, electric flux is radially outwards. You have studied. In the case of plus Q, it is radially outwards. In the case of minus Q, radially inwards. In the case of radially inwards. Radially inwards is in the case of negative charges, and in the case of positive charges, it is radially outwards. Here, electric lines of force, electric field, they start from positive end. You see, they start from positive end to the negative end. That is this, you see here, this electric field, electric lines of force passing from positive to the ends in the negative charge. In the same way, this electric field line is starts from positive and it ends in the negative charges. In the same way, these are the electric field lines, they start from the positive end to the negative end. For the dielectric dipole mode, for the electric dipole, they always starts from positive end to the negative ends. So that is, this one is like this. They never intersect each other. They will cross the another electric lines of force. They never intersect each other. They always start from positive to the negative end. So you see. And in the case of plus charges, for 2 positive charges, they start from, this is also start from positive charge. This charge is also start from positive charges. So they will not intersect each other. They will go in this direction. So it will not intersect each other. So this is electric dipole. So this diagram is very important. It is already asked in the July 16th, and model question paper also. This question is there, very important. You have to write it, you have to learn it, you have to practice it. So sketch the electric field lines in the case of electric dipole. So, and 2 equal positive point charges. This is start from positive and negative charges. This is for electric dipole, that means plus and minus charges, and this is for 2 positive charges. The plus charges is like this. You have to write it. And mention the properties of electric field lines. It is very important question. You see, mention the properties of electric field lines. This question is always, it is a common question. This question is always asked in the March examination. So March 16, 17, 18, 19, 20. In the coming year 20, 21 also it comes here. Very important questions. So this is very common examination. 20, 21, 22, 23 also it is a very common question. In the July examination, in the previous class I have written one question. What are the properties of electric charges? So that is all. That question always comes on July examination, and this question is always meant for March examination. So that is the question paper idea. So you have to learn it very well. So what is the mention the properties of electric charges, electric field lines? Electric field lines start from positive and ends in a negative charges. One question. Number 1 point is electric field lines start from a positive charge and end on a negative charge. Electric field lines do not intersect each other. They will not intersect each other. Electric field lines do not intersect each other. Electric field lines do not pass through the conductor. You see here, if a conductor is kept here, this conductor kept here, the electric field lines do not pass through this conductor, or this conductor it will not pass through this. It is always perpendicular to the conductor. The electric lines are always perpendicular to the conductor. Electric field lines do not pass through the conductor, and electric field lines always perpendicular to the surface of the conductor. So this is a conductor, it will not pass through this line. It is always perpendicular to this conductor. Electric field lines do not form any closed loop. You see here, it will not come, this suppose positive charge is there, it will not comes in this loop. it will not form any loop. So this is always start from positive to the negative end. Suppose positive charge is there here, it will not form like this. It will not. It is always starting point. It will not come from again to this. You see here, it is always it does not form a closed loop. So this is the characters of the electric field. Once I am explaining, electric field lines start from a positive charge and end on a negative charge. Electric field lines do not intersect each other. Electric field lines do not pass through the conductor. Electric field lines always perpendicular to the surface of the conductor. Electric field lines do not form closed loop. So these are the points you have to remember. It is very important. Underline this question. Mention the expression for the electric field due to a point charge placed in vacuum. Suppose there is a point charge is there. So mention the expression for this electric field lines. Expression for this. There is no derivation. Only formula is there. So there is a point charges. If there is a point charges, if we keep it in a vacuum. Mention the expression for this electric field. Electric field due to electric field means around this charges the field will be formed. So that is the electric field. Electric field is there. So what mention the expression for the electric field due to a point charge placed in vacuum. So this is electric field E is equal to 1 by 4 pi epsilon naught into Q by R square into R cap. R cap is a unit vector. So what is the E means electric field. PQ is equal to point charge. R is equal to distance between point and charge. R cap is equal to unit vector. 1 by 4 pi epsilon naught is equal to constant. Epsilon naught is equal to permittivity of spaces. Phase space. Permittivity of phase space in the medium. This is a medium. Vacuum or air or wood. That is the medium. So that is it. So 1 by 4 E is equal to 1 by 4 pi epsilon naught into Q by R square into R cap, where E is equal to electric field, Q is equal to point charge, R is equal to distance between point and charge, R cap is equal to unit vector, 1 by 4 pi epsilon naught is equal to constant, E epsilon naught is equal to permittivity of free space. So this part. And write the expression for the electric field due to a system of charges placed in vacuum. In the previous classes, Coulomb's law you have studied, the system of charges Q1, Q2 you have studied in the previous classes. Same derivation is there, but it is not important in the examination, you have to remember it. So, one who want to get out of 100, 70 out of 70, then only those can only you read it. Otherwise, the students who want to get 50 out of 70, they have to read the underlined questions. So write the expression for the electric field due to a system of charges you have studied in the previous class. Let the Q1, Q2, Q3, Qn etc. is equal to system of charges. R1, R2, R3, Rn is equal to respective position vectors. From Coulomb's law and from principle of superposition, electric field at P is equal to E is equal to electric field at P is equal to the point, R is equal to position vector. So you are in the previous class you are take the common, that is 1 by Q1 by 4 pi epsilon naught you have taken in the common in the previous derivation. In this derivation 1 by 4 pi epsilon naught you have to take it, and Q1 by R1p R cap plus Q2 by R2p into R cap 2p plus etc. Qn by Rnp square into R cap personal. So that is ER is equal to 1 by 4 pi epsilon naught into I is from 2 to n QI by RIP into RIP cap. So this is examination, you have to remember it. I think it is not given, it will not give, definitely it will not give in the examination. So for the important questions, so much of questions are there for the important questions, and this question it will not give, just you have to remember it. So next, what is the expression, write the expression for the torque acting on an electric dipole placed in a uniform electric field. Explain the terms in it. So Yes, tau is equal to P sin theta. That is torque means that is coupling equal and opposite forces. If a uniform electric field, conductor is there, the electric field will acting together. So what is the torque? How it will rotates? That is the expression. It comes in the magnetism and matter. So this question, this is only expression for this. Right. So tau is equal to P sin theta, where tau is equal to torque, P is equal to dipole moment of the electric dipole, E is equal to strength of the uniform electric field, and theta is equal to angle between the direction of P and E. So that's question you have to do. And what is the effect of a non-uniform electric field on an electric dipole? Use here for non-electric uniform electric field. If suppose this is plus charge, another 3 minus 3 charges is there, it becomes a non-uniform electric field. So what is the question for this? How it will there? In a non-uniform electric field, an electric dipole experienced both in torque and movement net force. Here it is a plus 1 charge, it is a minus 3 charges. It becomes a non-uniform electric field. So it becomes a torque. It starts rotating this. If it is a plus 3 charge, it is a minus 3 plus 5 charges, it starts rotating. What is the torque acting? That is the question. In a non-uniform electric field, an electric dipole experienced both torque and net force. That is there. So that is this is the questions that comes in the examination. What are the important questions? I will explain. I will say in. I will. Once again, I am saying in 3 times, and 1 time without seeing and 1 time with seeing. You have to write it. First you have to see. By seeing 1 time you have to write it, and another time without seeing you have to write it in a rough book. Before that you have all these questions and answers that you have to write it in our notes. You have to take it. Next one is memorizing part. Right. Next one is the memorizing part. Each and every question and answers I will say in 3 times, and in the rough by seeing 1 time and without seeing another time you have to write it. Yes. Mention the SI unit of electric flux 2020. It comes here. Newton Coulomb per meter square. Newton per Coulomb per meter square. Newton Coulomb per Coulomb meter square. Electric flux is a scalar quantity. Write the expression for the electric flux through a surface. d phi is equal to E into delta S is equal to E into delta S cos theta. d phi is equal to E into delta S is equal to E into delta S cos theta. d phi is equal to E into delta S is equal to E into delta S cos theta, where d phi is equal to electric flux, delta S is equal to area of small element, E is equal to electric field, theta is equal to angle between the direction of electric field and normal to the surface. E is equal to d phi is equal to electric flux, delta S is equal to area of small element, E is equal to electric field, theta is equal to angle between the direction of electric field and normal to the surface. D phi is equal to electric flux, delta S is equal to area of small element, E is equal to electric field, theta is equal to angle between direction of electric field and normal to the surface. Yes, this one. By seeing 1 time without seeing another time, you have to write it in a rough. Next, what is an electric dipole? Very important question. An electric dipole is the set of 2 equal and opposite point charges separated by a small distance. An electric dipole is the set of 2 equal and opposite point charges separated by a small distance. An electric dipole is the set of 2 equal and opposite point charges separated by a small distance. Its unit is meter. Meter is its unit. Next, what is the net charge of an electric dipole? 0. What is dipole moment? Very important question. Model question paper. It is there in the 2021. Dipole moment of an electric dipole is the product of one of the charge and the distance between the 2 point charges. Dipole moment of an electric dipole is the product of one of the charge and the distance between the 2 point charges. Dipole moment of an electric dipole is the product of one of the charge and the distance between the 2 point charges. SI unit is coulomb meter. SI unit is coulomb meter. By seeing one time, without seeing another time, you have to write it in the rough. Dipole moment is a vector quantity. Dipole moment is a vector quantity. Next, what is the direction of dipole moment? Dipole moment vector is directed from negative to the positive charge along the dipole axis. Dipole moment vector is directed from negative to positive charge along the dipole axis. Dipole moment vector is directed from negative to the positive charge along the dipole axis. Mention the expression for dipole moment. So, P is equal to Q into 2D or P cap is equal to Q into 2D into P cap. P is equal to Q into 2D, P is equal to Q into 2D or vector P is equal to Q into 2D into P cap. Vector P is equal to Q into 2D into P cap, where P is equal to dipole moment, Q is equal to charge, 2D is equal to distance between plus Q and minus Q, P cap is equal to unit vector along the dipole axis. P is equal to dipole moment, Q is equal to charge, 2D is equal to distance between plus Q and minus Q, P cap is equal to unit vector along the dipole axis. P is equal to dipole moment, Q is equal to charge, 2D is equal to distance between plus Q and minus Q, P cap is equal to unit vector along the dipole axis. So that is by seeing with one time, without seeing another time, you have to write it in the rough. Next diagram, by seeing and without seeing you have to write it in the rough, these two diagrams. Next, mention the properties of electric field lines, very important. Electric field lines start from a positive charge and end on a negative charge. Electric field lines start from a positive charge and end on a negative charge. Electric field lines start from a positive charge and end on a negative charge. The next point, electric field lines do not intersect each other. Electric field lines do not intersect each other. Electric field lines do not intersect each other. Electric field lines do not pass through the conductor. Electric field lines do not pass through the conductor. Electric field lines do not pass through the conductor. Electric field lines always perpendicular to the surface of the conductor. Electric field lines always perpendicular to the surface of the conductor. Electric field lines are always perpendicular to the surface of the conductor. Fifth one, electric field lines do not form any closed loop. Electric field lines do not form any closed loop. Electric field lines do not form any closed loop. Next, mention the expression for the electric field due to a point charge placed in vacuum. Electric field E is equal to 1 by 4 pi epsilon naught into Q by R square into R cap. E is equal to 1 by 4 pi epsilon naught into Q by R square into R cap. E is equal to 1 by 4 pi epsilon naught into Q by R square into R cap, where E is equal to electric field, Q is equal to point charge, R is equal to distance between point and charge, R cap is equal to unit vector, 1 by 4 pi epsilon naught is equal to constant, epsilon naught is equal to permittivity of free space. You have to write it in the notes, rough, one time and without seeing one time. So, write the expression for the electric field due to a system of charges. From this to this, you have to write it in a rough by seeing one time without seeing another time. So, next, write the expression for the torque acting on a electric dipole placed in a uniform electric field and explain the terms. Tau is equal to P sin theta. Tau is equal to P sin theta. tau is equal to P E sin theta. Tau is equal to torque, P is equal to dipole moment of the electric dipole. P is equal to dipole moment of the electric dipole. P is equal to dipole moment of the electric dipole. E is equal to strength of the uniform electric field. E is equal to strength of the uniform electric field. E is equal to strength of the uniform electric field. Theta is equal to angle between the direction of P and E. Theta is equal to angle between the direction of P and E. Theta is equal to angle between the direction of P and E. Next, what is the effect of non-uniform electric field on an electric field dipole? In a non-uniform electric field, dipole experienced both torque and net force. Dipole experienced both torque and net force. Dipole experienced both torque and net force. So these you have to write it by seeing one time and by without seeing another time you have to write it in a rough and next one. So okay, you have to write it properly. Before that you have to write all these in the notes, and in the rough by seeing one time and without seeing another time you have to write it. Okay, you study this and okay, best of luck.